Okay, let's take a look at question 2 here. It says that the function g is defined for x greater than 0. You're given g of 1 equals 2. So that's a given. You're given g prime and you're given g double prime. Find all values of x in the interval from 0.12 to 1 at which the graph of g has a horizontal tangent line. So all I did for this was I graphed. I put into my y1, I put in g prime. Okay? Make sure you're in radian mode. And then what I did was I changed my window to go from x. I just did 0 to 1. Actually, no, I did do 0.12 to 1. And then what are we looking for to see where g has a horizontal tangent line? We want to see where that first derivative crosses the x-axis, okay? And this happens when x equals 0.359 and x equals 0.163, okay? Then it says on what subintervals from 0.12 to 1, if any, is the graph of g concave down. So what tells us concave down? Our second derivative, okay? So at that point, I graphed my second derivative. So now I changed my y1, or you could even change it to y2 if you would like. So I put into my calculator 1 minus 1 over x squared times cosine x plus 1 over x, and we're looking again for where is it concave down. So I want to know when is this less than 0, okay? So that's what we're looking for, is when is this less than 0, because then it'll be concave down. So when you look at the second derivative, it equals 0 at 0.129 and 0.223. So if you check your signs, it looks like this. So we can say that it's concave down on the interval 0.129 to 0.223 because g double prime is less than 0 on this interval. Okay, now let's look. Part C, write an equation for the tangent line to the graph when x is 0.3. So we need the slope when x equals 0.3, which we can do very easily because we have our first derivative. So we will go ahead and plug in 0.3. And calculate that. And so that will give us negative 0.47216103333. Gave us a lot of decimal places. So that's our slope. We need an x and y for our point, and we're doing this when x is 0.3. But we don't know our y, okay? So again, this is our slope. So what we're going to use is our first fundamental theorem of calculus, because we're not given our original function. All we're given is the point g of 1 equals 2, okay? So we know that the integral from 0.3 to 1 of g prime equals g of 1 minus g of 0.3, okay? And we're going to use this to solve for g of 0.3 right here. You're going to use your calculator to calculate this, and then you're going to solve this equation for g of 0.3. So when we do that integral there from 0.3 to 1 of g prime, we end up getting 0.453999279. I'm just putting all the decimals. G of 1 is 2. We're looking for g of 0.3. So if I add g of 0.3 to the other side, and I subtract that 0.453999279 from 2, I get this long decimal. So now we have our point, okay? So to find the equation of a line, we do y minus y1. And at this point, I will go ahead and round to 3 or truncate, equals our slope of negative 0.472 x minus 0.3. So that's your point slope form. If we solve this for y, I'm just going to add the 1.546. And I noticed none of their answers ever really distribute that through. So we'll leave it in that form. And then part D, so that was part C. Part D, does the tangent line to the graph of G at 0.3? So does this tangent line lie above or below the graph of G for the interval from 0.3 to 0.1 and Y? Okay, so we do want to kind of figure out what our graph looks like here. Okay, so a few things that we can use is first of all, we know that our rate of change at 0.3 is negative because our slope of our tangent line is negative, and we calculated G prime of 0.3 and got a negative value. So you know it's decreasing there. So let's look at concavity. So let's look at our G double prime. We have this up here in red, but it doesn't go from 0.3 to 1. So we do want to make sure that our number line is with that interval. We know that first zero is 0.223. I'm putting it there just because it's close to 0.3. And then you want to figure out where is G double prime 0 again, and that actually happens at 1. So when you test these intervals, this is positive, this is negative, okay? So what's happening on our graph here is at 0.3 comma, what's our x value? 1.5, 0.3, 1.5, or 0.5, 1.5. So I'll just put that here. We have this negative tangent line, right? And from 0.223 to 1, this graph is concave up. Okay, so we know that this tangent line, because of that second derivative being positive and our slope here being negative, that the tangent line must be below our graph. Okay, so we can say, since G double prime is greater than 0 on this interval, then G of x is concave up. And since the slope of the tangent line is negative, the tangent line is under the curve. Okay, so we can take a look at their rubric. So in part A, it gives you a point for setting G prime equal to 0, which we did. Gives you a point for your answer. For part B, it gives you a point for answer and justification. So the graph is concave down on that interval, and I'm wondering why they rounded it to 4 decimal places and not 3. The graph is concave down on that interval, and our justification is because G double prime is less than 0. So you want to make sure, though, for your justification that, remember, you label that number line, okay, so we can clearly see it's negative. So that's something important to do. 3, you need to find your slope, so that's 1 point. Then they have the integral set up to solve for G of 0.3, so that's another point. Then you actually solve for G of 0.3, and then you have your equation. And so here they rounded to 3 decimal places. I don't know why they didn't up in B. It's a little bizarre. And then for D, just answer with reason. So this says that G prime or G double prime of X is positive for that interval. Therefore, the line tangent to the graph of G at 0.3 lies below the graph of G for that specific interval. So that's where you end up getting your 9 points, okay?